Hello everyone, welcome to the third 5G Mobix webinar. My name is Barbara Bazdeki and I'm working at ICCS. I'm responsible for leading the dissemination activities of the 5G Mobix project and I will be moderating our discussion during this webinar. Please let me tell you a few words about the webinar. Our consortium organizes this to present the main objectives and activities of the Greek-Turkish Cross-Border Corridor of the 5G Mobix project. The webinar will provide an overview of the corridor along with the challenges addressed. It's also an opportunity to exchange information regarding the 5G network infrastructure and features, the automated control of the vehicles, as well as the rest of the developments that will enable the Greek-Turkish trials. The webinar will also explain the user stories designed for platooning with See What I See functionality and assisted border crossing, summarizing the work made so far by the consortium in the Greek-Turkish cross-border corridor, but also it will present its future steps. Finally, there will be an interactive session and we'll have some time for Q&A. Before we start, let me briefly introduce you our speakers. Sorry for this. So with us, we have Dr. Nazli Güney, who works at Turkcell as the 5G project coordinator of the 5G R&D group. In the 5G Mobix project, Dr. Güney acts as the leader of the Greek-Turkish corridor. Mr. Ioannis Masmanidis works in Ericsson, Greece, and he is engaged with several market units. His current focus area is network functions virtualization infrastructure solutions for 5G network and telco cloud transformation. Also, Mr. Tahir Sari is with us. He is a connected and autonomous vehicle engineer working in Ford, Turkey. He also leads vehicle connectivity related European projects. Finally, we listen Mr. Kostas Trichas, who is an electrical telecommunications and computer engineer working at Wings ICT Solutions, Greece. He is currently serving as a technical coordinator of the 5G Mobix project and as quality managers of the Horizon 2020 5G EVE projects. So this is our agenda. Okay, I'm sorry, but this is our agenda and the topics we're going to discuss. Let me remind you that the whole webinar will be recorded and will be available at the project's website as well as the speakers' presentations. If you have any questions, please write them in the chat box and mention the speaker that the question is addressed to. As we said, your questions will be answered at our Q&A session at the end. So now I would like to give the floor to Nazli Güney.
Yeah, hi, good afternoon. First, I will be giving an overview of the Greek-Turkish cross-border corridor, and then the rest of the presentations will follow. I'm working for Turkcell. Turkcell is a mobile network operator based in Turkey, and we're leading the Greek-Turkish cross-border corridor and the 5G Mobix project. But before I talk more about what we're doing in the Greek-Turkish corridor, I will first give a very brief introduction to 5G Mobix project, its objectives, and the trials that are going to be conducted in the coming few years. And then an overview with location information, our partners, the user stories and the challenges we're trying to address in those user stories, and a roadmap. So 5G MOBIX, what distinguishes 5G MOBIX from the other connected automated mobility projects is that we're working in the cross-border corridors. This adds a more challenging dimension to the testing of these applications directed towards cooperative connected automated mobility, because as we all know very well, automated mobility is the future of the automotive sector. There are a lot of R&D activities going on in that dimension. And we're also looking into connected vehicles. And this is something we're already working on. But the cooperative dimension, it includes various stakeholders in the traffic. So there's going to be many actors working together to solve the issues we bring into the table in this project. But the most challenging here is cross-border corridors. So what we will do in the project is to execute CCAM trials and to identify the benefits of 5G to CCAM, and in the end, identify standardization and spectrum allocation gaps. And the business side, what we're trying to do is accelerate deployment of 5G. So we're working on deployment scenarios, doing cost-benefit analysis, and looking into new business opportunities for 5G. And in all of this, we have to look into legal, regulatory, and security issues in this project. So what is 5G MOBIX about? We have two cross-border corridors. One is connecting Portugal to Spain here. And then we have the Greek-Turkish corridor. And we also have four other European trial sites. Germany, Netherlands, France, and here Finland. And we also have South Korea and China in the project. On the network side, activities are ongoing to deploy 30 5G genome beads that are going to be having the NSA architecture in the beginning. And we're also looking into opportunities to evolve to SA if the equipment supports the SA architecture during the time frame of the project. We're going to having 24 SAE level 4 automated vehicles for 5 use case categories that are based on the 3GPP-TS 22186 spec. That's service requirements for enhanced V2X scenarios, where we will be having advanced driving, that's more focusing on the cooperative dimension and vehicles platooning, extended sensors, that requires very good uplink, and remote driving, again, focusing on the uplink, and vehicle QoS support. So if we go to the Greece-Turkey corridor, what we see here is a very congested, hard border area at times, especially during the holiday season, where you see a huge queue of both passenger vehicles and trucks that are trying to pass the border. Because it's a hard border with passport checks and paper checks and administrative details. And we have two real borders. The one on the up here, it only allows passenger vehicles. So if we are going to be using trucks, then it's not an option for us. And the other gate, border gate here is Ipsala-Kipi. It allows both types of vehicles, passenger vehicles and bigger vehicles over a bridge. So this is going to be our trial location in the 5G MOBIX project. If I can go to the next slide. Sorry. Okay. So we'll be using the Ipsala-Kipi cross-border site in the project. But we need border crossing permissions because this is a hard border and involves the public authorities on both sides of the border. I mean, looking at the nature of this border site with a lot of traffic and queues at certain times, we cannot do all the testing there. Instead, what we're doing is using Fort Otosan trial site that's situated in, in the Marmara region of Turkey here. And we're going to be using that area for long-term functionality development testing and transferring our equipment tested, verified to the cross-border site in the end. We went to this Fort Otosan area last year in August to check how the existing connectivity and existing sites performance is. So we saw a very good coverage there, and we believe this with the site upgrade to 5G, it will be good to cover all the required use cases at the plant in the beginning, and then transfer cross-border site as we have planned. So I've already told you one of the partners. It's Ford Otosan as a truck manufacturer. And we also have Turkcell here, Cosmote on the Greek side as a mobile network operator, and the Ericssons on both sides, Ericsson Greece, Ericsson Turkey. They're going to be deploying the 5G network test architecture with the NSI option. And for onboard unit developers, we have WINS and EMEC. And for the RSU, we're working with EMEC again, Belgium. And CCAM application developers are WINS, Ford Otosan, ICCS, and TÜBİTAK Bilgem here. When we look at all of the stakeholders, it naturally includes the partners of 5G Mobics, but we also have a number of public authorities that support this project. It's the Ministry of Infrastructure and Transport and Digital Policy, Telecommunications and Media for Greece. And on the Turkish side, we have the Turkish Ministry of Transport and Infrastructure and the Information and Communication Technologies Authority for frequency regulation that support this project. We also have the Customs Agency on board. And they're very supportive. In fact, we made a visit in August 1st last year to see the area. What we had there was, we went to see this X-ray area because when you're traveling from Turkey to Greece, depending on the decision of the border personnel, you may have to go into an X-ray check in that direction when you're traveling in that direction. Currently, we have a truck that has X-ray equipment in it, and you have to go through, you have to park your truck and then just move away, or your vehicle. And when the X-ray operation is finished, you go back. So that's a lot of time wasted there. That's what we saw. And we went onto the rooftop to see, actually there's a construction going on there. On the Turkish side, Uppsala border, the site is being renovated. There's a new border area, custom zone. And what we're going to be having at the end of this year is this area, and that is where we're going to be having our tests. So if we go to the next slide, I have to stop this. Okay. And I will ask Julia to, show the video for us.
It seems we had a problem with an audio problem with the video.
No, audio is fine.
Okay.
It's just music playing around, so you don't have to hear the video. What you have to see is this a lot of more lanes, and it's a much bigger area. And so it's going to allow us to do much more different things in this new area. This is just an overview of our user stories. We have these for Otosan in the project. They're a truck manufacturer, and they already have a future vision of providing a level 5 fully driverless truck, a future vision. And on this path, what they're working on at the moment is level 4 automation, and platooning is one of the use cases they're actively working on. And in this project, we're going to be doing platooning first. And for vehicles platooning, it's some kind of extended census. You're going to hear more about these during Tahir's presentation, which is going to be coming next after Jan's presentation on 5G networks. So you're going to be hearing the details. This is just an overview. But we go into the customs area. You cannot continue in a platoon naturally. And what we do there is some kind of truck routing to go to the X-ray building autonomously so that the drivers have more time to do their paperwork and carry on platooning following the customs site. That's the idea of this use case. And the other use case is assisted border crossing. It's aiming to expedite the passing from one area to the other, from one country to another. As you can understand, the goals of our user stories are mostly focusing on this hard border nature of the project. So we're trying to use 5G to come up with some novel solutions and some ideas to make the border crossing much easier for trucks that are important for the whole economy because of the cargoes they're carrying, cargoes and goods they're carrying. So we're trying to attack real problems that we encounter in our normal lives. So it's not just a technical show in our case. And we have a lot of challenges we have to look into. These challenges and more information about the user stories can be found in the specifications on use cases, deliverable 2.1. You can find it on our project website. So there's a lot of information about these. Both platooning and assisted border crossing user stories, use cases. We're addressing things like NSA roaming latency because we have two NSA networks on both sides, and switching from one network to another causes some latency. And we're also looking into low coverage because these services, CCAM services, are critical. It's not like you're watching a movie on your handset terminal. So we need high SLAs and good connectivity. These are things we're looking into. Continuity is important, and connectivity. So on the application side, V2X continuity and real-time processing of information coming from many stakeholders, and geopositioning, because the accurate location of these vehicles really important and very critical. On the security side, we're looking into trust. We need a trust model and a certification policy, and anonymization techniques should be applied on both sides. So we're also looking into law enforcement because absence of procedures is a problem. And these are autonomous vehicles, so who's going to be responsible for problems? And geodependent spectrum is related with the neighboring countries not having the same radio frequency spectrum. These are some of the problems we're looking into, and more information can be seen in our deliverable 2.1 on the project website. So this is a roadmap. This is where we are now. Just open the pointer. So we're here, and specifications are mostly done. We're trying to finalize development activities and starting integration and verification. In the fall, we will be beginning with early trials, and in the beginning of 2021, we will start the cross-border trials. In the meanwhile, for the business and impact work, we're trying to look into technical business, user acceptance type of deployment studies, and dissemination and communication continues after the COVID-19 pandemic more intensely. At the moment, we're doing some kind of paper publishing, this kind of webinars for dissemination. And next, we will be discussing 5G networks, our 2 different user stores, vehicles, onboard unit, roadside units, different presenters. If you have any questions, you can just drop it in the chat box in the Q&A part. We will be answering those during the Q&A session. Thank you.
Thank you very much, Nazli, for this presentation. We will go now to the next speaker. Ioannis, would you like to present?
Okay, my name is Ioannis Masmanidis. I work for Ericsson. I'm part of the 5G network deployment team on the Greek side. What I'm going to present to you is, let's say, a few words about the background, okay, and the framework for the network deployment, the 5G network architecture, and a few words on the RAN deployment. Okay. As Nazli stated already, we have a number of issues to explore, okay, and a number of functional and non-functional requirements to solve, to fulfill, which are guiding actually our choices for the network architecture. In this slide, I will present few of them, okay, the most important ones that have an impact on the decision related to the network architecture. Okay, the first key requirement was that we need to provide an architecture that is feasible for commercial deployment by the MNOs in the short term. So we should avoid big bang implementations, but follow a progressive and risk-contained evolution. That means also that the new infrastructure needs to be well interoperable and also coexisting with existing MNOs legacy systems. This is a basic requirement, okay, so that any transformation proposal that needs to be directed to the MNOs should motivate the business case and not show just barriers. So we need to have a pragmatic, commercial, viable approach. At the beginning of the project, we had the trial horizon of 2020, meaning that the first live show demonstration should be done around May 2020. Of course, due to a lot of reasons, also global situations, we have shifted the program, and now we attempt to have the first live showcases in around Q1, Q2 next year. Okay, this though does not impose any changes on the architecture. So the infrastructure that we provide needs to be future-proof, okay, and aligned with state-of-the-art developments and innovations. So the infrastructure needs to be able to evolve to support deployment of 5G use cases at a large scale, okay. This is the one side. On the other side, we want to see also deployments that motivate for new business models, new players to be able to provide and manage this infrastructure. We will come later to that. One big issue, as Nazli also mentioned before, is the roaming architecture. International roaming needs to be supported for V2X communication cases at large scale. So the switching of a vehicle when it crosses the borders to the new MNO needs to perform in a way that the strict requirements related to the latency, but also service continuity need to be fulfilled. We all know today the roaming architecture and the solutions that are provided are centered around a single human user individual. That means the solutions support a human individual that travels outside the home operator mobile network. It does not support connectivity of vehicles at scale, but also globally. Okay, this imposes few limitations and quite important limitations today to deploy V2X applications. One has to do with the business aspect, that due to the fact that fees are only partly regulated, okay, they do not allow to have a, let's say, cost prediction of what the connectivity will cost when, let's say, deploying V2X use cases. So the cost side is not predictable. On the technology point of view, there are three main limitations. The first one is that connectivity is today's solution offer only basic connectivity and communication. It does not support more advanced services like we will have in cross-border use cases with, let's say, advanced service and capacity requirements. The second limitation is that the roaming architecture is based on the home routing model. That means the traffic travels towards the home network and comes back. Okay, even if this architecture is sustained in our proposal, what we need to see to make sure here is that delays, okay, through the roaming network are reduced. Okay, so we need to provide fast connectivity between the deployment sites. And the third, which is, let's say, the most important limitation, is that the mobile, when it roams, it loses connection and sometimes can be up to 120 seconds, even more, or a bit less. This comes from the fact that the mobile, after releases his own connection.
Dear Ioannis, sorry for interrupting you. Sorry for interrupting you, but it seems that your slides are not moving. Could you please?
No, I didn't move yet. I didn't move yet the slide.
Okay.
Okay, so
okay.
I'm still on the slide. Okay. So I was saying that the connection is interrupted because the terminal, after releasing the old connection, needs to scan for frequencies in the new country to find the best frequency from the, let's say, roaming partners to come on. Okay, and this causes quite long interruption problems. And the last, issue that I mentioned here is that roaming interconnection between MNOs need to support QoS SLAs, especially when user plane traffic needs to be handled. Today, we know that roaming interconnection are based on GRX 3PP solutions, okay, provided by third-party operators. And in case that we enforce quite long delays, we need to find alternative solutions. Okay. And all this, as I mentioned before, so the model that we, let's say, the solution that we provide, it needs to be supported by an ecosystem that involves many stakeholders on each side of the border. So everybody needs to commit on that. And on the other side, everybody needs to have motivation, okay, to invest resources in that trial or in that, let's say, business case development. Okay, for that, our choice was, first of all, to select the NSA option 3 architecture. This is more or less to cover the first requirement, which is to be, let's say, feasible for commercial launch soon. Cosmote in Greece has already started to deploy 5G NSA, the 5G NSA commercial architecture, and we know that Turkcell has plans for next year. So it is an excellent opportunity to show to the operators real use cases that they can launch from day one and can be supported by the benefits of the radio NR architecture, but also the new roaming solution. The solution is, let's say, provided as overlay network. That means is fully separated from the commercial network, and this to avoid those interdependencies that we may expect from, let's say, parallel commercial and trial deployment. We use an edge deployment based on virtualized distributed EPC architecture. Okay, this gives us the opportunity to have a very low cost infrastructure deployed at the edge, an infrastructure that can be supported also by the edge facilities today. Okay. So due to the fact that we need fast connections, we have analyzed three options to use the GRX interface or a combination for signaling GRX, but direct interconnection for payload or a direct interconnection between the sites. So we chose the last question because the last option because some initial measurements that we did on the GRX, it showed around 200 milliseconds delays on the signal path. So that brought us to the, let's say, decision to use a direct interconnection that both MNOs will provide between the main sites, the edge sites, where the trials will be conducted. Okay, now related to the roaming solution, as I said, service continuity is a very, let's say, key aspect of the architecture, so that we still use home-routed roaming with session continuity. Though the new thing here is that we provide a new interface, the S10 interface, that we do not find today in any commercial deployment. Although this S10 interface is, let's say, standardized and solutions available to the market, no operator has decided to use this methodology. And this S10 interface can bring two improvements. One is to reduce the interruption time during handover to a minimum, up to 1 second maybe. In some, let's say, cases, test beds, we have seen that. Using this release with a direct method, which means once or by releasing the old connection, the network forces the terminal to use a specific frequency on the new mobile operator. So instead of scanning, direct it to a specific frequency to specific, let's say, radio access networks. And this can only be achieved by exchanging the UE context over the S10 interface. And another step of improvement is the S1 handover, which really is performed with session continuity. We may lose some packets, okay, on the way, but we still maintain the connection. What happens here is that before the old connection is released, okay, a new connection is created, and this again information transferred over the S10 interface to indicate which is the target in OB, and also for the home MME to select the target MME. So these are the two key improvements that we will see in our trial, and this will be probably one of the, let's say, early use cases that we can have on a commercial NSA system. So the moving of the slide is really very slow. Okay, now this is the, let's say, deployment architecture. So we have two edge sites, one at Alexandroupolis on the Greek side and one at Kartalets in the other side of the border. Okay, so in each of the two edges, we have a virtualized packet core infrastructure, which has all elements which are needed to handle 5G users and 5G connections. So we have the CUDB included, the HSS, the MME, the packet gateways, and also supporting functions for managing the solution. On the remote sites, we have also an OSS installation, which give us the opportunity to remote, let's say, connect to the system and do operations. So the edge applications are connected over the SGI interface, okay? And we also allow for local access, but also for internet access for the use case to be performed. The direct connection here, as I said before, we have, let's say, experience around 200 milliseconds delay. We get, let's say, figures from the transport layer that this connection can have 7 millisecond round trip delay on the transport layer. Okay, we can add some few milliseconds on top for the gateways between, let's say, the endpoints, but this will, let's say, be in no comparison to the 200 milliseconds. Okay. Good. So we build new sites. Okay. So the new E node B and G node B are new sites that are connected to sites that are already existing in the network. There will be one site at the Greek border and 4 sites in Turkey, and we will see that also later. One thing to say here more is that this infrastructure, okay, can evolve in different ways. We can evolve this to support also SA by adding the concept, let's say the functions, implementing the concept of the dual mode core, as we call it in Ericsson, where NSA and SA functions are deployed together to have, let's say, a common NSA-SA architecture. We can go also to a model, we can say, okay, this can be seen as a private network. So there is a new MNO or even the MNOs themselves that they deploy a totally separated private network to serve the, let's say, the automobile industry with new use cases. So both options are possible here. And having this virtualized infrastructure here, we can provide really a very compact solution to address a quite, let's say, adequate number of vehicles across the border. So for the RAN architecture, I don't want to spend too much time because I guess everybody that knows NSA understands what it is. So the basic concept is we use 3GP R15 NSA and dual connectivity towards the UE. As I said before, E node Bs and G node Bs are new nodes that are installed on the same sites.
Ioanni, sorry for interrupting you again, but could you please have in mind that you have 1 minute left?
Okay, good.
Thank you very much and sorry.
Okay, no problem. So actually, it's an overlay network. As I said, we will define specific cells and define their tracking areas that only the specific SIMs that using this network need to can camp on this network. Okay, on the Greek side, we have one physical site. Okay, E node B and G node B. We use the LTE band 2.6 gigahertz with 20 megahertz bandwidth. And on the NR frequency, we use the 3.5 to 3.6 megahertz MIMO. So since Cosmote has already deployed TDT for LTE, then we are aligning towards the current commercial deployment model and use, at least at the beginning, the same TDD frame format. And for synchronization, since those sites can be very far from central DCs, we have as an option to use the GNS-based synchronization. On the Turkish side, we have 3 sites, actually 4 sites. The 3 sites are across the border, and the 4th site is in a nucleus at the facilities of Ford, where Ford can do the initial tests. So we use the same frequencies on the LTE, but on the NR we have, let's say, we use the 3.6 to 3.8. So on the Turkish side we have 2 cells per site, and we use carrier aggregation. Just to say that, to show again in the map, this is actually the area where the trials will happen. There are those 3 sites, okay, on the Turkish side, and the 1 site in Kipi. So this corridor is around 10 kilometers, around 2.5 to 3.2 kilometers at the Greek side, and the rest in the Turkish side. So we have, let's say, across this road, we will have the, let's say, platooning and see what I see application. On that side, we will have the, let's say, assisted cross-border and automatic driving. And once we leave this area and we go to the Greek, we again resolve the platooning and see what I see use cases. These are some predictions that are done for a commercial tool used by Ericsson. We see here these initial gaps that they were shown. But as I said, we decided to put 2 cells per site so that we cover, let's say, perform an adequate coverage so that the handovers are really seamlessly, even the roaming case. So in order not to
yes, Ioannis, could you please sum up? Yes.
So all in all, we decided for a 5G NSA architecture, because this is the first step that we see operators that are doing, and we need to show the value that they can gain from this network architecture also in the vehicle to X use cases. Thank you.
Thank you very much, Ioannis. We'll continue with our next speaker, Tahir Sari, but before that, please let me remind you that if you have any questions, write them in the chat box and mention the speaker that the question is addressed to. Thank you. Tahir?
Hello, everybody. This is Tahir from Ford. Oh, let me share my also webcam. I hope you see me well. Oh, like this. Okay, perfect. And I'm presenting, yes, right now. But when okay, so today I'm going to explain about the vehicle development for Greece-Turkey cross-border. We are going to provide 2 tracks for this use case, for the platooning use case and assisted cross-border use case that my colleague Kostas will briefly explain soon. Okay, for the next page, if I may pass. Yes, let me show you a layout. Briefly, I will explain first the track information and then the platooning with see-what-I-see application. I will explain the use case briefly, and also an early implementation video you will see. And we have a collaboration with our Finland colleagues from Aalto, and for the video streaming, I will explain briefly on that. And the track routing in the custom side, I'm going to explain, and at the end, I just want to briefly touch what is the current gaps from OEM perspective. Okay, the track information. In 2019, we won the International Truck of the Year with our Ford F-Max truck. And for this project, we will equip this truck with this micro Autobox D-Space product. This is a prototyping ECU. And with the help of this ECU, we will connect the vehicle CAN with other ECUs, and also with the HMI Levis client and the onboard unit. Levis client is developed by the Finland team, and it's about video streaming. And the vehicle CAN is the standard protocol, and it collects all data from the camera, radar, brake module, engine control module, and steering module. So what we will do is mainly on this micro autobox disk space. And what it is, let me touch it a little bit. So we will collect the C-V2X modem onboard unit information like a speed, gap, the vehicle platooning, vehicle and platooning information, etc., and the sensor information and the HMI. With the help of this decision maker that we are going to develop inside of the micro autobox, we will do some decisions such as the extend the gap, close the gap. And to do this, we need to control the ECM, engine control module, and the steering control module. So steering control module is responsible about the lateral control, and the engine control module mainly responsible about the longitudinal controls, speed up, speed down, etc. So if we talk about the platooning with C/IC application, let me explain first what is platooning. Platooning is actually the vehicles moving to each other very closely with the help of the connectivity, and close means like a 1 second distance, and it is around, it depends on your speed, but for the vehicles we can say like a 10 to 15 meters, and the reduced distance with the help of this close distance, we will reduce the fuel consumption, and also we will reduce the space that the trucks take place on the road. And of course, to accomplish this, we need some automated maneuvers, such as the increase the gap, decrease the gap. You will see very shortly a brief explanation video about this. And the vehicles share location, heading, speed, and their intentions, maneuvers. And we will use 5G UU interface. And also, in case of the connection loss, because of the 5G coverage currently on this project is quite limited on the border area, we will use the PC5 interface of the C-V2X connectivity. Okay, and the 4K video streaming will be done from the, let me show first how it is going to be. First, you will see like a touch screen on your IP, and with the help of this touch screen, you will able to search for a platoon nearby you, and then you can, if you find one, you can just press the join request button, and this request will be sent to the platoon leader. Let me go to the next slide. Yes, if platoon leader accepts your joining request, then this information also will be transferred to you through 5G UU interface. And also, when you receive this information, you will see the also location where you need to go, and on your HMI tablet. And with the help of this tablet, you will drive closely to platoon, and then the rest platoon controller will do. So when you just attach to platoon, the maneuvers will be done autonomously. So increasing the gap, decreasing the gap, braking, etc. It's all going to be done by the vehicle controller that we are going to develop, and some part we already developed, the micro autobox inside algorithms. And when you attach, again, you can also request the C/IC application. Again, from your HMI, just send request to cloud to see the streaming from the vehicle ahead. And this actually, what you will see is kind of this. In this image, you can see that the trucks are very close to each other, and the trailer of the next truck ahead might be quite huge and closing your gap. So it might cause you to depress a bit, stress a little bit, and also you are not seeing around very safe, because you are very close to this trailer. And with the help of this streaming application, you will see what is ahead of you. And in case of you want to left the lane, for example, left the platoon, for example, for from another highway exit, you can see whether this exit is empty, this exit is safe or not. So this is also going to help this safety. As next, I would like to talk about the streaming application. Streaming application is developed by ICCS and Aalto team. Aalto team is part of the Finland trial site. They developed this 4K, they developed this JSON client and live streaming servers. This JSON clients are going to be like a JSON. Live clients are going to be JSON TX2 from NVIDIA, and this client going to be encode the video and send it to OBU that is developed by the iMac, and also this OBU will again send the data through 5G to the streaming servers, and then this server again publish the data back to the OBU from the follower vehicle, and this OBU will send again via Ethernet connection to the Levis client on the follower vehicle, and follower vehicle will Levis client will decode the video and show it on the HMI screen on your truck, in your truck. At this point, before passing the track routing application, I would like to ask Julia to show our video previously that we developed about platooning. Okay, thank you, Julia. That was the video about the platooning and its controllers. This is developed by Ford Otosan jointly with AVL team, and the controllers mainly developed by the Ford Otosan, and we will improve our controllers in this project 5G Mobix for the better and smooth maneuvers. So the track routing in custom site application, this is the other use case that we have. So let me explain about it, if I can. Yes. So this is actually, let me briefly explain about the application. Here the trucks, as you saw from the previous video, are not going to equipped with the high level sensors such as the lidars and the stereo cameras, etc. They will all have the standard regulative sensors that today we see on the vehicle, on the road. And with the help of these roadside units, we will publish the sensor data from these roadside units to TÜBİTAK Cloud. TÜBİTAK develops our track routing application in their cloud, and with the help of this track routing application, with the help of also 5G UU interface, our onboard unit also placed in our vehicle will receive the safe waypoints and follow the route without any intervention by the driver. So in case of course safety reasons, driver can of course will be stay in the on the seat and will intervene. But here our idea is having a vehicle level 4 capabilities without such high priced equipments, with the help of the sensors equipped on the field, not inside of the vehicle. And the vehicle will follow the safe waypoints. Let me also explain how it is on our scenario explanation. When Platoon reaches some point, and there will be a sign, track routing application is available in this border, and you will see an application button or a kind of HMI on your dashboard, and you can just press the button of the enable this application, and application will be enabled. At this point, you don't need to touch any controller, etc. Just follow the cloud directions, safe waypoints, and your truck has to be first checked by the X-ray, and this X-ray controls will be done by autonomously again with the help of the TÜBİTAK developed cloud, and the images will be examined. The X-ray images will be examined by the TÜBİTAK cloud, and if everything is okay, then you are ready to go, and you can come back to your vehicle and then drive to exit. Here is the X-ray building we would like to show on an image, and if everything is okay, your vehicle can go ahead again. These are all these maneuvers going to be autonomous with the help of the truck autonomous application that is developed by the TÜBİTAK cloud. Okay, what about the current gaps from OEM perspective? So this project is also mainly touching the first point. We don't know when we will see the common 5G deployment around EU highways. So if the vehicle have this 5G equipment onboard units, but there is no 5G common usage around, then it's going to be useless. And about revenue stream, we don't know currently how to do this. There is no such a rule between the partners, of course. And we are going to share some data from vehicle, and in exchange, we are going to receiving some maneuver information, etc. So how is going to be the data, for example, payment? How is going to be the revenue stream between the partners? And also the autonomy regulations between, for example, Turkey and Greece might be different. Also other countries, if we think about EU and non-EU countries, if one country obey the autonomy regulations and the next one is not, then how to act? We should know that. And the GDPR, the same. Between the neighbor countries, these GDPR rules might be different, and in this case, how to act, we need to know. And of course, the main one of the main gap is the cybersecurity concerns of the 5G. Okay, this is all from my side. Thank you very much. Please write your questions, and we will try to answer all of them right at the end of this webinar. Thank you.
Thank you very much, Tahi. And now we have the presentation of Kostas Trichas. Kostas, could you please present?
Right. Thank you so much. I'll also try to be as brief as possible, so we'll keep as much time as possible for our Q&A. So I'm going to be talking to you about the OBU and RSU development in the Greek-Turkish corridor, and of course about the assisted zero-touch truck border crossing use case that Wings is leading, and what we're going to do about that. So first of all, as an overview, in the Greek-Turkish corridor, we're developing 2 onboard units that will go into the Ford truck that Tahir just described, one from IMEC and one from Wings. There's going to be 3 roadside units developed by IMEC, and of course, we're developing 3 applications for the equivalent use cases that we have from Wings, ICCS, and TÜBİTAK. The IMEC OBU and RSUs will be used for the two use cases that Tahir just described, the platooning with C and the autonomous truck routing in customs, while the Wings onboard unit will focus on the provisioning of the assisted zero-touch truck border crossing use cases. So that's what I'll go into in a little while. But first, let's go over the OBU, the OBUs that we're going to be using. So you can see here the architecture of the OBU developed by IMEC. It's going to have both 5G and network communication capabilities and CV2X communication capabilities. Of course, we're using also 4G anchor for a remote recovery. It's going to be connected to the micro autobox and to the 4G ECU that Tahir just described before, and of course acting as a gateway to forward any information related to autonomous driving. You can see here the original build of the unit with all the chipsets and the hardware that we're using. Actually, right now we're in the process of upgrading those units with the 5G connectivity based on the Quectel chipset that we are about to receive within this week. And of course, it's going to be connected to the Ford truck OBU. Besides the IMEC OBU, as I mentioned, Wings is also developing our own OBU to support our use case. You can see it on the right-hand side. Along with all the sensors that are going to be connected to it. We have a carbon dioxide sensor, NFC readers, proximity sensors, GPS sensors, and of course the connectivity to the ECU of the truck. The main functionalities of these units are, of course, to send the autonomous driving instructions necessary for the Ford truck to operate in autonomous mode in the customs. It's to assess the risk level of its incoming truck by collecting this information and cross-referencing it with other information we have available from neighboring authorities or from the truck's manifest. And foremost, to protect the customs agents, as the customs site is actually a very vibrant site where multiple vehicles and personnel coexist, and we want to be able to protect the customs agents that are on site and to avoid any accidents. So right now our unit is ready, and again we're in the process of upgrading it with a 5G chipset that we just received last week. Besides that, we have the roadside units developed by IMEC. You can see here their architecture. We're going to use 3 of them. They are going to be connected also to a LiDAR that's going to be providing very useful information. And of course, and they also are good with CV2X communication capabilities. They're going to be very useful in the first 2 use cases that Tahir just described. You can see on the right-hand side here what they look like, their hardware, the antennas and LiDARs that we've been using. And of course, that's also mounted there, as well as the 5G chipset that we're going to upgrade them with, again, by Quectel, ensuring 5G connectivity for us. This is in terms of OBUs and RSUs. So I'd like now to go into the assisted truck border crossing use case. What we're doing in this use case is that we're utilizing artificial intelligence and predictive analytics to basically perform threat classification and assessment of incoming vehicles. We're doing that by based on the information collected by the onboard units and sensors of the truck, from the information of the roadside infrastructure and the cameras that we have inside, for information from neighboring authorities, and we fuse all this heterogeneous information, provide some intelligence. The end game here is to provide what we call a zero-touch border crossing to trucks. That would mean that we could verify all the information about this truck and we consider it a very small threat. Then no manual inspection would even be needed by the customs personnel, and they could quickly go on to their way. I'll go into the different scenarios that we support with this use case. So first of all, we can search and detect human or livestock smuggling attempts. We've seen actually in the past year that this was an issue with immigrants trying to sneak in the cargo holds of trucks. Some of them unfortunately even died. So this is actually a very major issue. We can try and detect that based on carbon dioxide emissions in the cargo hold, and we can even trigger higher events such as X-ray machinery, etc., in order to verify whether this is the case. And based on what our sensors detect, we can direct the truck to autonomously drive either to a high-risk potential lane for further inspection. That's what you see in the top right picture. If we assess that a truck is of high risk of smuggling humans or livestock, then we instruct it to autonomously drive to the X-ray machine or for further processing by the customs agents. Otherwise, what happens in the bottom picture might take place, where we say, okay, we've checked that there's no illegal attempts here, and they can just go through the customs. The second scenario regarding cargo smuggling attempts, that's trying to illegally pass any items or products that have not been registered and not mentioned in the manifest. We can try to monitoring that through various technologies by monitoring what's being loaded and unloaded from the truck using NFC, RFID. There are various alternatives there. And once again, the decision will be to instruct the truck to either proceed for further manual processing by the customs agents, or we assess that there's a low risk of smuggling here and they could go on their way. Finally, as I said, one very important use case is to protect the customs agents, as it's a very the traffic intensity of the customs side is extremely heavy. And then based on various sources, such as proximity, LiDAR, GPS coordinates we can receive from the smartphones or the tablets of the customs agents, we can detect a collision trajectory and intervene, ask the truck to stop autonomously and protect any human personnel on ground. In this flow diagram, you see actually how this the Wings intelligence platform works. You see that we collect all the data from the ONBU and the truck sensor that's being transmitted to the cloud application. It can be deployed both to the cloud or at the edge for latency issues. We collect the data from street cameras, thermal cameras, drones, or traffic sensors that we might have. We collect also the data from customs agent devices, as we said, and then combining that with information from the neighboring authorities, performing data fusion and applying our intelligent algorithms, we can foresee and detect all these events and send the corresponding instructions or data to the agencies. We also provide very useful and insightful graphical user interfaces, or GUIs as we call them, to the customs agents, to the truck driver, to help them go through this whole process. And here I just wanted to give you a quick overview of how this information flow are going in this use case. So we have the truck and all of its onboard sensors and the GUI of the truck driver on the bottom right. Then of course we have the custom sites and the roadside infrastructure with the camera, the smart toll gates, the smart traffic lights, etc., that we can also communicate with. And of course, the information from the neighboring country authorities. Each and every one of those devices is, of course, transmitting information that's arriving to the intelligent Wings platform. Right now, I'm just showing the example where the platform is deployed at the cloud, but it works equally well and even maybe better when deployed at the edge, as the latencies are supposed to be reduced. And now the idea of the use case is, as the truck will move and will cross the border, it will attach to the neighboring side. We will reestablish all connectivity to the platform. There's quite a few challenges there on how to intelligently do that and not lose sight of this truck. And again, the whole goal here is to resume communication with the platform and with all the key stakeholders of this use case. What enables that is, as I mentioned, this data ingestion and analytics software that we've developed within Wings, basically collecting all kinds of information from heterogeneous data sources. As you can see, the input of the algorithm contains multiple sources, from GPS to CO2 to cargo IDs, etc., and it outputs an even larger amount of information, informing both the customs agents and the truck drivers about what needs to happen, but also issuing the autonomous driving instructions towards the truck of where it should go based on this input. You will see an example of these two graphical user interfaces in a minute as I present basically the video. I'm going to show you a small video. As I mentioned, we've been in the process of development for quite some time. We have developed the functionality, and now we're just upgrading to the 5G chipsets and the 5G communication capabilities. But I would like to show you a video of an early implementation where you can see this functionality. It's based, of course, not an autonomous vehicle right now, but it's a first proof of concept and implementation of what our OBU and platform can do. And what's remaining now is after we connect it to the 5G network to integrate it to the Ford truck. But hopefully you will understand a bit better what this use case is about and what our OBU and platform can do. So Julia, can you please share the video? All right, that was it as first small proof of concept where everything actually worked except for the autonomous vehicle, which is the last step where we need to integrate with Ford truck. That was it for me, and I'm going to pass the floor back to Barbara to lead us through the Q&A. Thank you.
Kostas, thank you very much for your presentation. It was really very interesting. And now we will try to answer some of your questions. I think we have about 10 minutes to do so. So in case we run out of time, we'll try to answer all of the questions via email and upload them in the project's website. So we have several questions so far. I see one from Jerry that says, I think it's addressed to Tahir. So it says that, Tahir, you mentioned there are gaps regarding cybersecurity concerns. Could you speak to the scope of ongoing efforts as well as whether or not this effort is primarily in-house?
Yeah, thank you for question. Actually, this is not scope of this project, but for our use cases, we will use a whitelisting IPs. All IPs will be registered previously on the clouds, so there won't be any unknown IP registration possibility.
Okay, thank you very much. So one question for Ioannis. Can you give more detail about the required flexibility and scalability? Scalability with respect to what? Flexibility with respect to what?
So I already tried to answer in the chat. Okay. Scalability is actually how we can deploy this solution at large scales, including more cross-border sites, for example. Okay. And in terms of flexibility, as already said and explained in the chat, we need to be able to provide different configurations to support the different use cases and different models. So this distributed architecture can be, let's say, reconfigured to allow for new functions, or let's say place at a different site, not the full configuration, but only the user plane. Okay, having a real, let's say, distributed MEC architecture can also be deployed in a way as it is now with additional sites in terms of a private networking. Okay, so to support a new service provider that is focusing on cross-border business. Okay.
Okay,
So
thank
this
you.
more or less, yeah.
Thank you, Ioannis. I don't know if you have answered one more question that is for you. It says that I noticed that Ericsson is MNO provider on both sides. What is the impact of such situation? Is the proposed solution easily adaptable to cross-border with different providers?
Yes, actually, I was about to answer this in the chat. The functionality we provide are actually standard 3GPP functions. I mean, we may do optimizations now and then in our products, but the main functionalities that I was talking about, even for the roaming scenarios, are, let's say, standard 3GPP functionalities that should be supported by all vendors. So in that solution, there is really nothing proprietary. As I said, optimizations, of course, by the vendors are already always done.
Mm-hmm. Okay. There was one question that maybe it has been answered already by Tahir's presentation, but I don't know if you would like to add something, Tahir. It says that the remote driving UC seems the most challenging. Can you tell us more about and what is its feasibility? Tahir, I cannot hear you.
Yes, sorry, I was
Okay.
This was, I think, about the track routing in the customs area, and we did some measurements about roadside unit sensor uplink capacity, and it was about 30 megabit per second, and we are going to use like 2 or 3 sensors for the uplink, and the camera CCTV going to be around placed, of course, and this is will be connected fiber, and we will because of the current 5G uplink possibilities, we will have 100 megabit per second uplink, and we will use it all. For now, it is just a proof of concept, but in the future, with the extent of the 5G capabilities, I believe this is going to be feasible more. By the way, we are going to transfer the raw sensor data instead of object data of the sensors. That's why we want to challenge the 5G as much as we can.
Okay, thank you very much. We have one question from Khaled. It says, do you succeed to have a zero disconnect of a vehicle? I don't know which one of the speakers would like to answer it.
Can you
Maybe I
repeat the question?
Yes. Did you succeed to have a zero disconnect of a vehicle?
I think
Yes, but this is, let's say, more or less on known test, let's say, test environments. Okay. So this will be probably one of the cases that we need to prove it at, let's say, a more public event. Okay.
if I may also jump in here, sorry, Barbara, but that's a good question because it provides us the opportunity to clarify something. So as most European projects, we've also had an impact from the COVID-19 lockdown and measures. So as such, we were supposed to already have first measurements, etc. But unfortunately, because everything froze for 3 or 4 months, equipment was not delivered to us. We couldn't go in the field and deploy the network. We're still not there. Even the chipsets that I mentioned that we're using, and I see questions about the chipsets, I can repeat that it's from Quectel, the chipsets that we're using. They were only delivered to us now, and that's an engineering sample, which we will later also upgrade. So as Yanis said, we've tried a few things in testing environments, but our trials have not started yet. This is something that, as per Nazli's roadmap, will start this fall.
Thank you very much, Kostas and Yanis. So another question from Martin. Do you plan on using the European CCMS, or do you have a partner who is going to create a separate CCMS just for this project?
That's a good question. I think we'll have to get back to you on that based on our experts on the system, which are not all in-house in Greek-Turkish Corridor. I think it's EU CCMS is the one of the options we're examining. But let me get back to you on that because I don't want to give you false information right now, as I don't have the exact answer.
Okay, thank you very much. I think we have one question for you, Tahir. It says, what is the incentive for joining a platoon for letting other tracks joining instead going on my own?
Okay, this is actually the application related question. I can answer. You need to send the join request first to the platoon leader. If he or she accepts this join request, then you are able to join. Otherwise, since you are following very close to each other, in case of any braking kind of maneuver, you will be in danger because you are following quite close distances. And about the going between the vehicles, it is of course again kind of very close, and the one track is around 15 meters, and the distance between two tracks is maybe going to again at most 15 meters. So it's not easy to just go inside between two vehicles. But of course, I see the question, and there are some projects about especially platooning, such as Ensemble, also Horizon 2020 project, and this is a open question that needs to be regulated, to be honest.
Okay, thank you very much, Tahir. So I think we'll try to answer the rest of the questions in via email or upload them in the project's website. Since we ran out of time now, I would like to warmly thank you, all of you who are participated in this webinar. I would like to thank the speakers as well as Ertico Academy for hosting this webinar as like the previous one. Thank you very much all and have a nice evening.
Thank you all for attending. Take care.
Thank you.
Bye.
Be safe.